Your EV isn't a black box. In 2 minutes, you'll trace how electrons flow into the pack when you charge and out to drive the car. The battery management system watches cell voltage, current, and temperature. It talks to the charger, sets safe limits, and decides when to slow down or stop charging, so you don't overcharge or overheat. For AC, the wall power is going to go to the onboard charger, and then it's going to be transferred to DC and then to the battery. For DC fast charging, the station sends DC directly to the pack. The BMS commands how much current it wants in real time. Charging follows like this: constant current first, which is going to be a fast fill, then constant voltage when cells approach their safe limits. Then the taper is going to happen. There's this tiny math you can use. Power is energy per unit time. For level 2, which is around 11 kilowatts, if your car averages 18 kilowatt hour per 100 kilometers, that's about 61 kilometers of range per hour. DC fast charging adds 150 kilowatts of energy at low mid state of charge, then tapers as you approach full state of charge. The cold raises internal resistance of the pack, which means that you will have slower charging and less regenerative braking. The hot weather triggers cooling and power limits. Many cars precondition the pack before a fast charge, so it's best to use navigation to the charger to enable it. How the car uses the energy: from the battery to the inverter, and then from the inverter to the motor. Efficiency is high, but some power becomes heat. The resistance times current square losses in the cells, bus bars, and windings. Higher current means more heat, so the car manages torque and cooling to protect the pack. Lifting off or braking turns the motor into a generator. The BMS limits regenerative braking by temperature and state of charge. Near full charge, or when it is too cold, the regenerative braking shrinks to protect the cells. The BMS usually blends Coulomb counting with voltage at rest models and temperature. If the gauge feels jumpy and occasional 100% on AC charging, plus 30 to 90 minutes plugged in helps to top balance the cells. Regarding safety, contactors open on severe faults. Isolation is monitored, and hardware fuses or pyro fuses can cut power instantly. That's why true overcharge is rare. So what do you need to do? Daily target 60 to 80% charging. Charge to 100% only when needed. Precondition before DC fast charging. Avoid sitting hot or at 100% state of charge for days. In winter, you need to expect slower charging and less regenerative braking. That's the whole loop. From grid to BMS, then to the battery is the charging, and from battery to inverter and then to the motor to drive is discharging, with temperature and voltage guarding longevity. Download the free one-page PDF EV charging and discharging explained. Link is in the description. Thank you.